Hello, welcome to my channel. In this lesson, I will be teaching complex numbers. We are starting with the introduction to complex numbers, and this is the part 1 of the introduction to complex numbers. For clarity and understanding of the concept, we shall distinguish between complex numbers and real numbers. It is important that we do that. So, we will talk about the imaginary units and then proper definition of complex numbers, and then we give examples of complex numbers. And I have a tip as regards how you should conclude answers when you come across complex numbers when solving equations. I will talk about that in the later part of the videos. Please do not skip any part of this video because every part is important for the understanding the concept of that which this video is all about. So without wasting time, let us start by unveiling the concept of complex numbers. So to start with is the real numbers. You can consider the real numbers as the set containing set of natural number, set of integers, set of rational numbers, and set of irrational numbers. So therefore, NZQ and Q prime are subsets of the real numbers. Basically, real numbers contains all numbers you are already familiar with. You work with them every day. Hence, for natural numbers, Z for integers, Q for rational numbers, and Q prime for irrational numbers. In this video, we will not be discussing in details every subset of R, but we shall give examples of such numbers. Any number you can think of always belongs to at least one of the subset of real numbers. For example, 1 belongs to all of subset of R, minus 2 belongs to set of integers Z, 1/4 belongs to set of rational numbers Q, and your pi, which is an irrational number, belongs to the set of irrational numbers, which is Q prime. Alright. So that is all about real numbers, and any number you can think of are all real numbers. Now, moving on to complex numbers, let us start with two sets of quadratic equations. So we have x squared minus 1 equals to 0 and x squared plus 1 equals to 0. Let's solve these two equations that we have. We have that x squared minus 1 equals to 0 and then x squared equals to 1. That implies that x equals to the square root of plus or minus 1. So therefore, x equals to plus or minus 1 in this case. And let's solve the second equation, the second quadratic equation that we have. X squared plus 1 equals to 0. Then we have x squared equals to minus 1 and x equals to plus or minus the square root of minus 1. Now, in the first solution, we got plus or minus 1, which is the set of real numbers, is a member of real number rather. Plus 1 and minus 1 are members of real number. So the solution to this is a member of real number. But how do we deal with this one, which we have plus or minus the square root of minus 1? In this case, we introduce the imaginary unit. So the imaginary unit I is taken as the square root of minus 1. That implies that the answer here is plus or minus I. So I is the imaginary unit. So our imaginary unit is defined as square root of minus 1. And this also implies that if I is the square root of minus 1, then taking the square of both sides, we get I squared equals to minus 1. So I is the square root of minus 1, or we can also say that I squared equals to minus 1. So with this, we understand what complex number is. This the idea of complex number. So we always see I everywhere when we're talking about complex number. So that's how we know we are having complex numbers. Now let's define proper complex number. Let's give the definition of complex number properly. So complex number, we can define it as C, that is the set of C, which equals to A plus the set of A plus IB, such that A and B are member of the real numbers. You know what real numbers are, I've explained that earlier. And such that I square equals to minus 1. This is the proper definition of a complex number. It is the set of A plus IB such that A, B are members of real numbers, and I square equals to minus 1. In some books, they write I equals to square root of minus 1 in place of that, but they are the same thing, as I've explained earlier. So if you are asked to define a complex number properly, that is how you define it properly, or let's say in general. Then let's give examples of complex numbers. Talking about complex numbers, our first example here, so let's take example 1. I itself is a complex number because we can write it as 0 plus 1i. Then the 0 is your A and 1 is your B. And I also need to mention this, that if you have A plus IB, A is called the real part in the complex number, while B is called the imaginary part, and I is called the imaginary unit. The common mistake that students make is writing IB as the imaginary part. IB is not the imaginary part. B is the imaginary part, while I is the imaginary unit and A is the real part. So you have to clarify that. Having just I here, I can be written as 0 plus I 1i. So let's take the second example. We have 5 minus 6i. 5 is the real part, minus 6 is the imaginary part, and I remains the imaginary unit. The third example, we have minus I. It can be written as 0 minus 1i. So this implies that 0 is the real part, minus 1 is the imaginary part, and I remains the imaginary unit. Let's move on to example 4. Cos 60 plus I sine 60. Sine 60 is the one with I, which is the imaginary unit, which we take as our imaginary part. The imaginary part is sine 60, and the real part is cos 60, and I remains the imaginary unit. So we have broken down all these concepts, and I hope that when we see a complex number, we can actually identify a complex number. So having that said, now let's talk about the tip that I have said I will mention. Let's revisit one of the quadratic equations we used while explaining the concept of complex number, which is x squared plus 1 equals to 0. If you were given this equation to solve from our earlier work, we know that you will arrive at x equals to the square root of minus 1. The question now is, how do you conclude on what your answer will be? Well, it depends on the condition given. Firstly, if it was stated that the equation was given such that all value of x are in the set of real numbers, since x equals to square root of minus 1 is the root, and this is not in the set of real numbers. In fact, you should not say that the answer does not exist or that there is no solution, as this is what we say in most cases. If you say that it does not exist, then you can be questioned that it does not exist where. So how should you answer this? So therefore, you should write that there is no solution. So you write that there is no solution in the set of real numbers, which is R. So this should be your conclusion. So you should not write there is no solution. No. The question will be that there is no solution where. Alright, let us consider another possibility. Let's say if it was not stated that the value of x is in the set of real or complex numbers, then we have to construct our answers in two ways. So we are still going to write that there is no solution in RAL, and then we also write that the solution in complex number. So we write that the solution in complex number is x equals to, that is x equals to I, or x equals to plus or minus I. So this is how you should give answers when you stumble on complex numbers when solving quadratic equations or equations higher than quadratic equations. And lastly, if you are already aware that you are working with the set of complex numbers, then you should not need to worry. You just write your answer as x equals to plus or minus I. Alright, that being said, with this we end today's lesson. If you like my video, please subscribe to my channel and let's engage by putting comment in the comment section just as feedback. See you in the next part. Goodbye.